Today we're going to start chapter 10, section 1, and we're going to cover how to solve a system of equations by using a matrix. Now, a matrix is just a rectangular array of numbers, and it's always described as rows by columns. So M, in this particular example here, it has M rows and N columns. So the rows go this way. Oops. And then the columns go up and down. So this, for example here, this would be a 3 by 2 matrix. What we're going to be doing on our matrices is different row operations. And if you think about it, we sort of did that already when we solved our system of equations. But the different row operations that we're going to be doing is we can either interchange two rows, so we can switch their spots. We can also do a column change. But the only time we can do a column change is before we start any calculations on our matrix. Row changes can happen anytime within the solving process. We'll also be able to multiply a row by a non-zero constant. So just like we did with the system of equations, when we did the elimination method, remember we multiplied the equation by some non-zero constant to get either the x or the y to cancel. We'll be doing the same thing here, except for when we set up our matrix, there's no variables in it. And then another way would be to add a multiple of a row to another row. So like if I wanted to maybe make it become a 0, I could add its opposite to that row to cancel it out. What we're going to be using is the Gauss-Jordan method or Gauss-Jordan method to rewrite the system, the matrix in echelon form. So it's like stairs. So we're going to be performing row operations to get our matrix to have this following format. So what I want is a diagonal row of ones, and then I want zeros above and below it. Now, what's over here in this very last column, this is going to be my solution. So for example, if this were x and a y, this would have been, if I put my variables back, this would have been 1x, this would have been 0xy, and then whatever number is here is what x would equal and what y would equal. So the number that is in this spot will be your x value, and then the number that's in this spot would be your y value, unless we did a column switch, and we're going to see that coming up. Now, notice over here in this little pink cloud looking thing, if all zeros are left, then it's going to be all real numbers. If you end up with a double zero here, and you're going to see it, it'll be no solution. And I'll show you what I mean by that. So let's go ahead and let's take a look at our first two examples. They're nice and easy. It's just two equations with an x and a y. So what I'm going to be doing is putting my system of equations into my standard form of my matrix. So what I'm doing is I'm going to add in just the coefficients. So remember here, in front of x, you're assuming it's a 1. Same thing here in front of the y. So when I go to fill it in my matrix, I'm just writing the coefficients. So I'm going to write 1, 2, 5, 2, 1, and then the -2. Now, on this side, on the right side of that gray line, maybe I'll do it in a different, on the right side of the blue line, the numbers that end up over here are going to be my solutions. Now, my goal here is to transform this matrix so it's like the identity matrix. So it's in echelon form, so it's like steps. So what I'm going to be doing is turning it into something that looks like this, with a diagonal row of ones and then a 0 up and above and below it. And then on the right side of the blue line is going to be my X and my Y value. So we're going to be doing different row manipulations, whether we'll be multiplying them or adding them to each other, or even doing a row switch. So again, when I'm labeling this, this is row 1, and this will be row 2. And I'm going to be using this naming convention to describe what I'm doing to each row. So my first goal here is I want to, whenever I want to change a number to become a 1, I can divide it by itself. Like if I wanted to change a 5 to a 1, I would divide that whole row by 5. If I want to change something to a 0, I'm going to add its opposite to it. And you're going to see what I mean by this. I know I'm saying a lot of things. So the first thing I'm going to do is I need to work it by columns. So I'm going to work down the first column, and my first goal was to change this first number here to a 1, because that's what I'm trying to make it look like. And it's already done for me. My next thing I need to work on changing is this 2 that's here. I need to make this become a 0. And the way that I'm going to do that is I am going to be taking row 1, and I'm going to multiply it by -2. Maybe I'll show the work over to the side here. Let me do that so I have more room here. So what I'm going to be doing is I'm going to be multiplying row 1 by -2, and then I'm going to add row 2, and then this is going to give me my new row 2. So once I distribute a -2 to row 1, I end up with -2, -4, -10. I'm going to add that to the current row 2, 2, 1, -2. And now my new row 2 is going to be 0, -3, -12. This is my new row 2. So I'm going to rewrite row 1, 1, 2, 5, with my new row 2, the 0, -3, -12. Now I'm going to work on the second column, but I'm going to work from bottom up now. Now, what I'm looking to change always in the next column, the first thing I want to change is the 1. So I'm trying to change this number that's here into a +1. And in order to get that to a +1, I'm going to divide it by itself. Dividing, my next row manipulation here is I'm going to take row 2, because again, if we want to keep the labels here until we're used to this, I'm taking row 2 and I'm dividing the whole row by -3. This is going to give me my new row 2. So row 2, 0, -3, -12. I'm dividing all of these by -3. 0 divided by -3 is 0. -3 divided by -3 is 1. And -12 divided by -3 is +4. This is now my new row 2. So now I have the row 1 is still the same. I'm rewriting my new row 2. And now I have one more thing to change. I need to change this too, so it's a 0. So now, in order to do that, remember we're going to add its opposite. And I'm going to use my row 2. So I'm taking row 2. I'm going to multiply it by -2. And then I'm going to add it to row 1. This will give me my new row 1. So -2 times row 2 gives me 0, negative 2, negative 8. I'm adding that to row 1. 1, 2, 5. And then I end up with 1, 0, negative 3. That's my new row 1. So 1, 0, negative 3. The row 2 did not change. And now I'm done. Because if you were to put the variables back, this is x equals negative 3. And then this is y equals positive 4. And you're going to write it as ordered pairs. Let's set it up, put in just the coefficients. And again, we want it to look like 1, 0, 0, 1. And then again, on this other side is going to be our x and our y. So let me go ahead and take just the coefficients. So I'm putting in 2, negative 3, positive 10, 2, 2, and 5. All right, so again, I need to work on changing this 2 so that it's a 1. And again, remember, to change a number to become a 1, we're going to divide it by itself. So what I'm going to be doing, my first thing that I'll do is I'm going to take row 1 and I'm dividing it by positive 2. This will give me my new row 1 with a 1 in that top spot. So here's my row 1, 2, negative 3, and 10. Divide everything by 2, and I get 1, negative 3 halves. I'm just going to leave it a fraction. And this is my new row 1. So 1, negative 3 over 2, positive 5, and then I'm rewriting row 2. I haven't done any changes to that yet. Now, my goal here is to make row 2. So again, this is row 1, row 2, row 1, row 2. Now my goal, my next step, is to change this 2 and make it a 0. And the way that I'm going to do that is multiply the row that I just made a 1. That's what I'm going to multiply by a negative 2 to make, and then add it to row 2. So I'm taking row 2. I'm taking row 1. I'm multiplying it by negative 2, and then I'm adding it to row 2 to equal the new row 2. So again, your pivot row is the row, the thing that you're going to be multiplying by is the row that you just made become a 1. My new row 1, or row 1 when I multiply it, is negative 2, positive 3, negative 10. Then I'm going to add that to row 2, 2, 2, and 5, giving me 0, 5, and negative 5 as my new row 2. So my row 1 stayed the same. And then my new row 2 is the 0, negative 5, or positive 5, negative 5. Now I'm going to work on the next column. I need to change the 5 into a 1. Because again, remember, this is what we're trying to make it into. And again, to make something become a 1, we divide it by itself. So I'm now taking row 2, and I'm dividing it by 5. This will give me my new row 2. So we have 1, and this should have been a 2, not a 3/5. Let me fix that. I don't know why I wrote a 5 there. This should be negative 3 over 2. Let me fill that in. negative 3 over 2. Okay, so now erase. Okay, so I'm taking row 2, 0, 5, negative 5, and I'm dividing it by 5. So now my new row 2 is going to be 0, 1, and negative 1. So this is new row 2. So now I'm going to go ahead and rewrite my row 1. So 1, negative 3 halves, 5, 0, 1, negative 1. Next, we want to change the negative 3 halves into a 0. And in order to do that, I'm going to multiply the row that I just made a 1 by positive 3 halves. So 3 halves times row 2 plus row 1 will give me my new row 1. So when I multiply row 2 by positive 3 halves, I get 0, 3 over 2, and negative 3 over 2. I'm going to add that to the current row 1, which is 1, negative 3 halves, and positive 5. I'm going to add up, and I end up with 1, 0. I need to get a common denominator here, so I'm going to change the 5 into 10 over 2. And then this gives me 7 over 2 once I do the math there. So this is now my new row 1. So I have 1, 0, 7 over 2, 0, 1, negative 1. I now have it set up as this identity matrix in my echelon form because I've got this diagonal row of 1s. So now my x equals 7 halves and my y equals negative 1. So as an ordered pair, 7 over 2, comma, negative 1. Next, we're gonna, again, we need to set it up so it's the same way. We wanna have the 1, the 0, the 1, the 0, and then what we end up with here is our x and our y. Now, it needs to be set up in this standard form. So I need to move, and this is missing a 0, I need to move the 10 over and the 15 over. So 2x minus 5y minus 10 equals 0. I need to move the constant to the other side. Same thing on the second equation. Whenever you're doing these matrices, make sure both equations have your x's lined up on top of each other and your y's and then the constants. All right, I'm going to go ahead and put it into my matrix with just the coefficients. So 2, negative 5, 10, 3, 1, and 15. Now, at the beginning, I told you another way to use these rules on these rows and columns is, in addition to just multiplying and adding them together, I can also switch the rows and the columns. And the reason why you would want to do this is in order to avoid getting a bunch of fractions in the problem. Now, I'm going to do number 3. I'm going to do it without switching any rows or columns. I'm going to do it and work with some crazy fractions. Then I'm going to show you how you can use the rule where we could switch the column to begin with. So let me do it first, just using the same techniques we've been doing, but we are going to get some fractions that we're going to have to work with. which is fine. So the first thing I want to do is I want to change this 2 to a 1. And the way that I'm going to accomplish that is I'm going to take row 1 and I'm going to divide it by itself. I'm going to divide it by 2. And that'll give me my new row 1. So 2 divided by 2, negative 5 divided by 2, and 10 divided by 2. So 1, negative 5 halves, and positive 5. That's going to be my new row 1. And already we've got a fraction we got to deal with. So 1, negative 5 halves, positive 5. I'm going to rewrite my original row 2. Now my next thing is to make this become a 0. And you're going to take the row that you just made the number become a 1, and that's what we're going to be multiplying. So I'm taking row 1, and I'm going to multiply it by negative 3, and then I'm going to add it to row 2. This is going to give me my new row 2. So once I distribute a negative 3 to row 1, I get negative 3. I get positive 15 over 2. And then negative 15. I'm going to write row 2 underneath it. So it's lined up here. These are simple calculations. But again, sometimes it's better to not try to do them in your head. 0. I could change my whole number 1 and make this 2 over 2. So this becomes 17 over 2. This is my new row 2. So row 1 is the same. My new row 2 is the 0, 17 halves, and a 0. Next thing I'm going to do is go over to the next column. I need to work on getting this 17 halves and make it become a 1. And in order to do that, we're dividing it. And remember, when you divide fractions, it's really like multiply by the reciprocal. So I'm going to take row 2 and I'm going to multiply it by the reciprocal of 17 over 2. Because again, remember, it's the same thing as saying row 2 divided by 2 over 17. This is the same thing. So once I divide each one of my row 2s, so this divide or multiply, let me do it multiply. That multiplied, and then 17 over 2 multiplied by the reciprocal, and then 0 multiplied by the reciprocal. This one was easy because we had 2 zeros already in the row. So my new row 2 is 0, 1, and 0. This is new row 2. Row 1 still the same. My new row 2, 0, 1, 0. Last thing I need to change is this negative 5 over 2. I need to make it become a 0. So we're going to take that row that we just made the 1 with, and I'm going to multiply it by the 5 over 2 and then add it. So I'm going to multiply row 2 by 5 over 2, and then I'm going to add it to row 1. This will give me my new row 1. So 5 halves, when I multiply that to row 2, I get 0, 5 over 2, and a 0. I'm now going to add that to the current row 1. And this will give me my new row 1, 1, 0, 5. And now I'll put that in here, 1, 0, 5, with the current row 2. And now it's in echelon form. And again, I have 1x equals 5 and y equals 0. So my solution is the ordered pair 5, 0. Let me come over here to the side. You can add another page if you wish. Okay, so the same beginning matrix. So I'm plugging in the 2, the -5, the 10, 3, 1, 15. I'm still trying to make it into that echelon matrix. All right, so remember, our goal is to change this to and make it a 1. What I'm going to do right off the bat is I'm going to switch my columns. Now remember, this was all the X's, this column was all the Y's, and this was the row for the constants. When I do a column switch, it's also going to switch where my answer is going to be. So I'm going to switch, and you can only switch columns before you start any kind of manipulation on the matrix. So I'm going to switch my X and Y column, and I'm going to put -5, 1, and then the 2, 3, and then this stays the same. And now what's happened here, initially, this was for X, this was Y. When you do a column switch, the order of the answers is also going to switch. Now, I'm also going to do a row switch. And when I switch my rows, then this 1 will come up to the top. So now I'm going to switch the rows. So I'm going to put 1, 3, 15, -5, 2, 10. Now, the variables are connected to the columns, not the rows, even though it's at the end of the row. All right, now I've already got my first 1 set up. My next step is to make this -5 become a 0. So in order to do that, I'm going to take my row 1 and multiply it by +5. So +5 times row 1, and then I'm going to add that to row 2 to get my new row 2. So when I multiply it, I get 5, 15, and 75. I'm going to add that to the current row 2. 0, 17, 85. This is my new row 2. So now let me write in 1, 3, 15. That row 1 stayed the same. Row 2 changed. Now my next step is to change the 17 to a 1. And again, in order to do that, you divide it by itself. So I'm going to take row 2, divide it by 17. So 0, 17, 85, that row 2, dividing them all by 17 is going to give me 0, 1. And then when I divide 85 by 17, I get 5. So this is my new row 2. So 1, 3, 15 stays. 0, 1, 5. I have one last step. I need to change this 3 to a 0. And the way that I'm going to do that is just now use the same row that I just made become a 1. So this row 2, I'm going to multiply it by -3 and then add it to row 1 to get my new row 1. So once I multiply row 2, I get 0, -3, -15. Going to add that to the current row 1. And then I get 1, 0, 0. And now I'll fill that in. 1, 0, 0. Rewrite row 2. And notice it's the same answer I got when I did it over here. Because remember, we switched it. This is Y, this is X. So 5, 0. So again, you can use the row and the column switch if you prefer to avoid getting fractions. It's totally up to you. Either method works, but just remember, if you do a column switch, it has to be at the beginning. Row switches can occur anytime, but you never want to switch something that's going to undo something you've already done. Let's try example 4. And let me just come over here and rewrite it. So I'm just writing in the coefficients. So 3, -2, +1, 6, -4, -1. Okay, so again, my first step is to change this 3 to a 1. So I'm going to take row 1 and I'm dividing it by 3. So 3 divided by 3, -2 divided by 3, 1 divided by 3. And then I get 1, -2/3, and +1/3. This is my new row 1. And then row 2, I haven't done anything to yet. So now what I'm going to do is I need to change this 6 into a 0. I'm going to take the row that I just made become a 1, and I'm going to multiply it by that opposite of 6. So row 1 times -6, add that to row 2, which will give me my new row 2. So once I distribute a -6 to each one of row 1, I end up with -6, +4, -2. I'm adding that to the current row 2. And I get 0, 0, -3. So now if I fill that in, my row 1 is -2/3, 1/3. My new row 2, this is new row 2. Now, when you go to change, my next thing that I would be changing is this 0. I can't get a 0 to turn into a 1. So as soon as you see that, because it would be undefined, I can't divide 0 by 0 and make it into a 1. Soon as that happens, no solution. So if you end up with a 0 in a spot that's supposed to be a 1, the answer is no solution. Okay, so next we're going to be solving a system, still using the same method, but we'll have 3 variables. So again, we still want it in this echelon form, like steps, where we have 1s all the way straight down the diagonal. The numbers that are going to end up over here are going to be our answers. So if it's an X, Y, Z, the answers we would get are going to be right there. And again, you're going to try to get zeros above and below. So let's go ahead and try our first example. So again, only write the coefficients. So for the first equation, I've got 1, 3, -6, +7. Then 2, -1, +1, +1. 1, 2, 2, -1. Now again, remember what we're working for is to get it to look like this. This is our goal, is to get it in that order with the 1 straight down this diagonal. So notice what was nice is my first row or my first spot here, it's already got a 1. So now I'm going to work on the 2 numbers below the 1. I need to make both of these become zeros. And again, I'm going to use that row 1 where the 1 is located, and that's what I'm adding to each one. So for my next matrix, what I'm going to be doing is I'm taking -2. Let me do this in a different color. So I'm going to be changing this one and this one. So for row 2, to get rid of that 2 to make it become a 0, I'm taking row 1 and multiplying it by -2, and then I'm adding it to row 2, and that'll give me my new row 2. So let me go ahead and do that. And then I'm also going to do change the row 3 as well. So multiplying row 1 by -2 gives me -2, -6, +12, -14. I'm adding that to row 2. And this gives me my new row 2. I'm also going to do the change for row 3 at the same time. So again, I'm changing the purple 1 to a 0. The way that I'm going to do that is multiply row 1 by -1 and then add that to row 3. This will give me my new row 3. So once I distribute the -1 to row 1, those are my numbers. I'm going to add that to row 3. Zero, -1, 8, negative. There should be a 6. Right, -7. So then this becomes a -8. All right, they're good so far. This is my new row 3. So let me rewrite my matrix. Row 1 stays the same. Row 2 became the 0, the -7, the +13, -13. So this right here. Then the purple is my new row 3. All right, now that my first column is done, I now can shift over and I need to start working on my second column. Now, what I'm working on is the 1 first, because that's also another name for it is like my pivot row, because that's what I'm going to be going ahead and multiplying by to cancel the numbers to become a 0. So what I'm going to be working on changing right now is, let's see, let's do it in blue. This -7 needs to become a 1. Now, row switch. Let's go ahead and multiply row 3. Now, if you see a 1's already appeared, let's go ahead and switch row 2 and row 3. So I'm going to switch row 2 and row 3. And then I'm going to have a 1 there after I multiply it by -1. So I'm going to do a row 2 and a row 3 switch. So let me just rewrite that. And then the purple will go here. And then the red will be below it. And now I still need to get it to be a 1. So now to do that, I'm going to take row 2 and I'm going to multiply it by -1 or divide by -1, whatever you want to think of it as, and it'll become my new row 2. So really what's going to happen here is all these signs are going to be opposite. So I could change this to a positive, a negative, and a positive. Now I need to work on changing the 3, which is above that +1, and the -7, and make those both zeros. So now I'm going to take the newly found row 2, and I'm going to multiply it by -3, and add it to row 1. And then I'm also going to multiply by +7 to row 2 and add it to row 3. This is going to give me my new row 1. This will give me new row 3. So let's go ahead and let me multiply row 2 by -3. And that'll give me 0, -3, +24, -24, added to row 1, 1, 0, 18, -17. This is my new row 1. Now I need to do the same thing and get my new row 3, which is the red. So I'm multiplying row 2, the purple, by 7. So 0, 7, -56, +56. Add that to row 3. And then this gives me 0, 0, -43, and +43. This is my new row 3. So now let me rewrite my matrix. So my row 1, 0, 1, 0, 18, -17. Then my new row 2, or my row 2 is the same. It's the purple, 0, 1, -8, +8. And then the row 3, 0, 0, -43, +43. I'm getting there. I'm not done yet. So now, remember, the last thing we need to change now is this last -43. And then to do that, all I have to do is take row 3. And I also have to make it a 1, but then I got to make the things above it a 0 as well. Okay, so I'm going to go ahead and take row 3, divide it by -43. So 0, 0, -43, +43. Divide these all by -43. And then I get 0, 0, 1, -1. So now I have 1, 0, 18, -17, 0, 1, -8, +8, 0, 0, 1, 43. I'm sorry, -1. All right, now I just have to take this newly found row 3. I'm going to multiply it by +8 and then add it to row 2. And then I'm going to multiply the row 3 by -18 and add it to row 1. All right, so for this one, +8 times row 3 is just 0, 0, 8, -8. And then I'm going to add that to row 2. So the 0, 1, -8, +8, 0, 1, 0, 0. So this is my new row 2. And then I have to get my new row 3, which I'm going to do this calculation. So 0, 0, 18, -18. I'm going to, actually this is my new row 1. So I add this to row 1. 1, 0, 18, -17. 1, 0, and this should be a -18, and that's a +18. So then this becomes 0, and this becomes a 1. And this is my new row 1. So now let me fill all this in. So my new row 1 is 1, 0, 0, 1. My new row 2 is that purple, 0, 1, 0, 0. And then the row 3, 0, 0, 1, -1. It was still right here. So now let me put the brackets around it. And again, here's my division. So again, this is x. So 1x equals 1. And then my x is 1. My y, the purple here, is 0. And my z is -1. And there is my ordered triple. So 1, 0, -1. One last example. Again, 3 unknowns. So again, remember our goal is to get it in this form. 1, 0, 0, x, 0, 1, 0, y, 0, 0, 1, z. So again, the numbers that are going to appear here will be the answers on that last column. So let me go ahead and add in my coefficients. So 1, negative